going to look at crossing our homework, looking at our homework from last night. We're going to examine our two heterozygous offspring from our F1 generation on the previous page. So our two gerbils are going to be pure black, or a heterozygous black parent with a heterozygous rough-coated. We're going to have another heterozygous rough with a heterozygous black. So those are our two parents. If you guys will all remember with me, we said we would always separate our gametes by drawing these arrows. So we would have one possibility that's big R, one that's big R, little r. We'd have one that would be little b, big R, and we're going to put that way. And we'd have another one that would be little b, little r. Since both of these are exactly the same, we're going to come right over here and we're going to do exactly the same thing. And that one's going to be our recessive. So as we look at this, we need to remember that when we fill in our Punnett square, we're going to be able to fill it in by doing this crossing motion. Keep your R in front because it's the capital letter of that trait. Over here, we're going to keep our B in front. Over here, we're going to have big B, big R, little r. As we move through this, you're going to quickly find that it's not very difficult. This we have homozygous for B's, we have homozygous for R's. This one, again, we have big R, little r, big B, two little r's. We have big B, two big r's. We have big B, big R, little r. So this one's a heterozygous. Okay? We're going to have two little b's, two big r's. We're going to have little b, big R, little r. Big R, little r. So another heterozygous. Two little r's. And this one's going to be completely recessive. As we look at this, then it becomes very easy for us to see that our difficulty is going to be in counting the number of genotypes that we have. So we're going to mark them out as we count them. So our first one is going to be completely homozygous, and we're going to have only one of those. Then we're going to move to this box, big B, big R, little r. And we're going to examine until we find another one. And here's another one. There should be no more of those, so there's two of those. We're going to go to this box now, and we're going to have heterozygous and two big R's. And we're going to look until we find another one, and here it is. So there's going to be at least one more of those, heterozygous and dominant for R. And so there's two of those. We're going to find this one, and that's going to be our 4 heterozygous genotypes. So we're big B, big R, little r. And there are 4 of those. And you're going to continue to move through this Punnett square, counting your genotypes. Let's take just a moment and look at our phenotype. If you'll remember back in class today, we said that every time you have 2 heterozygous parents who are heterozygous for 2 traits, we're going to have a phenotypic result of 9 to 3 to 3 to 1. In this case, since our phenotypes are fairly easy to determine, okay? Remember, we'll have 9 of them that will show the 2 dominant traits, black and rough. And that goes from the front of our homework paper. That's where we got those particular phenotypes. We're going to have 3 of them that will be black and smooth. This would be an example of an organism, an offspring that would be black. It has 1 dominant gene. It is completely recessive for the recessive trait of smooth. So it's black and smooth. We're going to have 3 that will be white and rough. They have no dominant gene for black. They're totally recessive for white, but they still have at least 1 big R, making them rough. So we would be white and smooth. We would finally have 1 individual that is completely homozygous recessive, and it's going to be white and smooth. Oh, and I wrote this one wrong. That one should be rough because it had the big R. I'm sorry, my mistake. 3 white and rough. So 9 black and rough, 3 black and smooth, 3 white and rough, and 1 white and smooth. This will be our phenotypic ratio. Go ahead and finish your genotypic ratio doing simple counting by looking at and examining the different genotypes. Please remember, this cross will allow you to end up with 1 offspring that shows the completely homozygous recessive phenotype.